Space, the final frontier. These are the voyages of the starship Enterprise. Its 5-year mission, to explore strange new worlds, to seek out new life and new civilization, to boldly go where no man has gone before.
Hi and welcome back. Today we're going to start with getting our Bussard control sketch transferred onto the ATtiny 85. So if we start, bring this up fully into view. So if we start with a blank sketch, completely new. First thing we need to do is open the file section, scroll down to preferences. It'll ask you for additional board manager URLs. I've already put this in there here, but in the description I will put the link, so all you have to do is copy and paste that link and put it in this additional board URLs. So press OK. So now we go up to tools, we come down to boards, select board manager, it brings this screen up, it should bring this screen up, scroll all the way to the bottom and you'll see ATtiny. Install this. So if we come down the bottom now, again, we can see it's installed. Close. Don't worry about these messages at the bottom. So now we need to plug in our Arduino Uno. Come up to File, scroll down to Examples, and then select Arduino ISP. Make sure you get Arduino ISP, select that. That opens up another sketch. You don't need to do anything with this sketch, it's set to upload it. Finally uploading. Done uploading. Right, so once we're done uploading, we can close that sketch and unplug our Arduino Uno. And it's now time to wire up, so I'll reposition my camera and we'll get the ATtiny wired up. Right, let's get this ATtiny wired up to take the program. I've put a couple of screenshots up here and both are in the description so you can reference back to them. But the first one's showing you that the ATtiny chip, and it's got a little indentation at the top, and then the pins count down 1, 2, 3, 4, back up the other side 5, 6, 7, 8, and pretty much every chip is the same. And I've also put up a little circuit diagram so you can reference back to how I connect these up now. So let's get this all connected up nicely. So we start with pin 1, which connects to pin 10. Then pin 5, which connects to pin 11. Pin 6, which connects to pin 12. You'll notice the Arduino is not plugged in. Never have your Arduino plugged in when you're wiring up, just to avoid any accidental shorts. So next is pin 7, and that goes into pin 13. Then we need the ground, so let's connect the ground rail. Maybe not with that wire. So our ground from the Arduino board goes to the ground rail on the breadboard. Then connect pin 4, which is the ATtiny's ground pin, to the ground, and we connect pin 8, which is the power in for the ATtiny. I've got that in the right line. And that connects to the 5 volt. And that's our ATtiny wired up, ready to transfer the code over. Okay, now you have the board connected up. Back into tools, down to board, right down to the bottom, and select ATtiny and the one that says 254585. Now back into tools again. Make sure the processor is ATtiny 85, and here it's already selected it. So back into tools again. Want our clock to be set at internal 8 MHz. Normally it'd set itself as a ATtiny 25, but it's been nice and remembered my settings. So we've got internal 8 MHz. So let's go down to programmer. Make sure the Arduino is as ISP, which it is. Make sure you don't select that one, it won't work properly. Don't select any of these other ones, it's Arduino as ISP. So now we can plug our Arduino in. Now we go back up to tools and we select burn bootloader. These chips should always already have a bootloader, but sometimes the manufacturers will save themselves a penny and be lazy and not put it on, so just burn bootloader every time and you won't have a problem. So it'll tell you at the bottom it's burning bootloader, it may take a minute. Done burning bootload. So now we can go to files and open the ATtiny 85 Bussard control that in the last video I said that you'd need to download. So that file's open. So now all we need to do is check all our settings in tools. Our board's an ATtiny 85, we're at 8 MHz and Arduino is an ISP. So everything's fine there. So we can go ahead and upload our sketch. If this takes too long to upload, I might edit this bit out. It doesn't seem to be too bad. Uploading. Done uploading. And that's our sketches transferred to the ATtiny. So let's have a look at it working. Right, so we need to connect all the wires now. So we start at pin 7. That connects to our red LED. Pin 6. That connects to our white LED. Pin 5 connects to our blue LED. Pin 2 connects to our green LED. And pin 3 connects to our yellow LED. Once again, pin 4 connects to the ground rail. And pin 8 connects to the power rail. I've left 5 volts from the Arduino wiring and ground wire from the Arduino in, but I'm not going to use them, just to prove that we are on the chip. We won't use the Arduino at all. Just plug in my DC and there we go. So the Arduino lights up because it's actually getting power from there, but I can take my ground out and my power out. Arduino's nothing to do with it and everything's just on that one separate chip. So on to our next part now. Right, so next let's have a look at connecting up the sound card and the speaker to the Arduino. These take quite a few of the wires up. So on the sound card we have 6 pins and it starts with ground, VCC, that's the voltage in, MISO, MISO, MOSI, MOSI, the SCK and the CS pin. So we have a few connections that we need to take from the Arduino first for power. So we need to connect our 5 volt to the lower power rail. Our VIN, which is voltage in, which if we add an external power source, I'm not going to at the moment, but that connects to the top power rail. This is for the speaker. Try to keep the wires over here out of the way so we can see. We need to connect the ground to the ground rail, and we're going to bridge both our ground rails So now we have power on both rails, and we have both rails grounded. So this card will sit in the breadboard. The pins are all nicely lined up to be able to do that. So our first pin, the ground, goes to the ground rail. Our second pin, the VCC, goes to the power rail. Our next pin is the, oops, I've got that in the wrong hole. Our next pin is the MISO pin, and that goes into pin 12. Then we have the MOSI pin, that goes to pin 11. And the SCK pin goes to pin 13. And finally, our CS pin comes down to pin 10. So as you can see, it's quite heavy on pin usage. This is why adding sound does take up a lot of the Arduino board. So next we will connect our speaker in. So the first thing is we need a 540N MOSFET transistor. So that fits into the board. Then from the first rail connects the Arduino on pin 9. Then we have our speaker, and if you're wondering why I've got this mad green speaker, I ordered some speakers off eBay that never turned up, and I was desperate for them, and I picked up a toy guitar in a charity shop for £1 just so I could get the speaker. It gave the woman in the shop a laugh, but I had to walk home with it. Right, so our negative lead from the speaker goes into the middle pin. Our positive pin from the speaker goes into the power rail on the top of the breadboard. The last pin on the MOSFET goes to the ground rail on the breadboard, and that will work. If you start getting any resistance, I've not had this problem, but put a 10k pull down resistor, let's move these out of the way so I can get to it, between the middle leg and the last leg, will cut down on interference. and that's how the soundboard and speaker get wired in. Very heavy on the Arduino. That's 5 pins used out of the 20 available, so a quarter of all the pins I had available have gone just to add sound into the circuit. But I think it's a worthwhile effect. I'll show you how to convert files into WAV format. I got all my sound effects and sound bites off Trevor's site. I'll put that link in the description as well, and I'll put the link to the WAV converter site in the description as well. So I'll just get that sorted and show you how to connect all that up. Right, so this is an audio converter. Convert audio to WAV. WAV is the format that Arduino understands. So we choose a file. I'm going to choose this phaser sound effect, which is MP3. Open it up. Downloaded already. Now we need to sort out these settings. Bit resolution needs setting to 8-bit. The sample rate needs setting to 16 kHz. And audio channels needs setting to mono. Then we just start conversion and download in about a minute. As easy as that. Okay, and the last thing I'm going to go over on this video is how I've connected the switches in. I know most people know, but just in case, it's always handy. So the pins, notice from the front you can see them, so I sit in. I've then straddled over from one side over the gully to the other, just to give myself some room, because there's only one line there and you actually need 3 pins in a row. So from the other pin, notice there's nothing in the middle, we're just going into where the pins are. That goes onto the ground rail. If you notice, I've got the Arduino 5 volts grounded, and I bridged both sides for the power. Where's my 10k pull down resistor? That's on this side, and that connects into the power rail. And then it just remains on that same one. This is R positive, and that connects up back onto the Arduino, and I'll connect it into hole 0 because I'm using hole 0 in our sketch, and it's that easy to connect a switch in to work on the Arduino. You must have the 10k pull down resistor though, because these are very sensitive otherwise and won't work. Right, I hope what we've gone through in this video is helpful and helps you, even if you're not using my sketch, helps you with some other bits. In the next video we'll get the main sketch onto the ATMega 328. We'll include all the libraries that we need to do, and we'll get the full circuit running without the Arduino, just using our DC regulator. But for now, thank you for watching. Keep trekking, keep modelling, and speak to you all soon.